Hello, my dear students. Welcome to IK Sir Chemistry classes. Here we are in lecture number 3 on solid state for chemistry students of class 12. This video will also be useful to JEE and NEET aspirants. First of all, we will see the components of a cube. A cube is given here. It is the edge of the cube, and this one is the edge center of the cube. It is face of the cube, and it is the face center of the cube. This point at which more than two edges of a system meet together is called vertex, and this point is the body center of the cube. Thus, there are various components of a cube such as edge center, face center, vertex, and the body center. Constituent particles of a crystal. The constituent particles of a crystal may be atoms, molecules, or ions. A few examples are given here. In the crystal of copper, the constituent particles are few atoms. On the other hand, in the crystal of rhombic sulfur, the constituent particles are S8 molecules, while in the crystal of sodium chloride, the constituent particles are Na plus and Cl minus ions. Thus, we see that the constituent particles of a crystal may be atoms, molecules, or ions. Now, let us discuss crystal lattice. There is a regular, that is ordered arrangement of constituent particles in a crystalline solid, which may be represented by points or spheres. In a crystalline solid, there is a regular, that is ordered arrangement of constituent particles in the space, and these constituent particles may be represented by points or spheres. The regular pattern of points, which describes the three-dimensional arrangement of constituent particles in a crystal, is called crystal lattice or space lattice. The regular pattern of points, which describes the three-dimensional arrangement of constituent particles in a crystalline solid, is called crystal lattice or a space lattice. Diagrammatic representation of crystal lattice. The crystal lattice of sodium chloride is given here, which consists of Na plus ions and Cl minus ions. It is obvious that Na plus and Cl minus ions have ordered or regular arrangement in the space in the crystal lattice of sodium chloride. Na plus ions occupy the edge centers and the body center of the cube. On the other hand, Cl minus ions occupy the vertices of the cube. At the same time, they also occupy the face centers of the cube. It is obvious that there is ordered arrangement of Na plus and Cl minus ions in the crystal lattice of sodium chloride. Components of crystal lattice. There are two components of the crystal lattice, and these are, first of all, lattice site. Each point in a crystal lattice, each sphere in a crystal lattice represents one constituent particle, which may be atom, molecule, or ion, and it is called lattice point. Please note it again that each point or sphere in the crystal lattice represent one constituent particle, and it is called lattice point. The site in a crystal lattice which is occupied by particle and denoted by point or sphere is called lattice site. The site in a crystal lattice which is occupied by constituent particle of the crystal is called lattice site, and each point in a crystal lattice which represents a constituent particle is called lattice point. The adjacent lattice points of a crystal lattice are connected together by straight lines to describe the geometry. The adjacent lattice points are connected together by straight lines to describe the geometry. And the second component of crystal lattice is interstitial site, the vacant space in a crystal lattice which is surrounded by particles, that is spheres or points, is called interstitial site or hole or void. Please let us see it again. The vacant space in a crystal lattice which is surrounded by particles or spheres, that is points, is called interstitial site or hole or void. It has been represented diagrammatically as follows. It is a portion of a crystal lattice. The sphere, the point which represents a constituent particle is called lattice point, and the site where a constituent particle may occupy is called lattice site. The sphere or the point representing the constituent particle of a crystal lattice is called lattice point, and the site where constituent particle occupies the space is called lattice site. And the vacant space in the crystal lattice which is surrounded by spheres or points or particles is called interstitial site or hole or void. Unit cell. The smallest three-dimensional collection of lattice points which sets a pattern for the entire crystal is called unit cell. The smallest three-dimensional collection of lattice points which sets a pattern for the entire crystal is called unit cell. Any crystal is made up of a number of unit cells arranged one over another. Any element is made up of atoms. Any compound is made up of molecules. any house is made up of bricks. Similarly, any crystal is made up of a large number of unit cells which are arranged one over another. Thus, the unit cell is the building block of the crystal. Diagrammatic representation of crystal lattice and unit cell. A crystal lattice is given here. It has ordered arrangement of cations and anions. It must be noted that the anions are present at the vertices of the cube, while the anions are present at the edge centers. These are cations which occupy the edge centers as well as the body center. The cations occupy the edge centers as well as the body centers. On the other hand, the anions occupy the vertices as well as the face centers of the cube. It is crystal lattice. It may be noted that this portion, this three-dimensional portion of the crystal lattice is repeated throughout the crystal, and this a smallest three-dimensional collection of lattice points is represented here, and it is called unit cell. Any crystal is made up of a large number of unit cells arranged one over another. In the present case, this crystal lattice is made up of 8 such unit cells. 1, 2, 3, 4 in the lower portion, and 1, 2, 3, and 4 in the upper portion. Overall, there are 8 unit cells in this portion of the crystal lattice. Unit cell parameters. 3 non-planar axes x, y, and z are selected to describe the geometry of unit cell. 3 axes x, y, and z which should be non-planar are selected to describe the geometry of the unit cell. The unit cell is characterized in terms of edge lengths along the axis, that is A, B, and C, and the interaxial angles alpha, beta, and gamma. Any unit cell is characterized in terms of the edge length along the axis A, B, and C, and the interaxial angles alpha, beta, and gamma. These are called unit cell parameters. Diagrammatic representation of unit cell parameters. A unit cell is given here. A is the edge length along the x-axis. B is the edge length along y-axis, and C is the edge length along the z-axis. Alpha is the angle between y and z-axis. Beta is the angle between z and x-axis, while gamma is the angle between x and y-axis. Types of unit cells on the basis of positions of lattice points. Depending upon the position in the unit cell which are occupied by particles, unit cells are of various types. First of all, unit cell is of two types. primitive unit cell, which is also called simple unit cell, and the other type is centered unit cell. The centered unit cell is again of three types: body centered unit cell, face centered unit cell, and end face centered unit cell. All these will be discussed in the next video. Thank you for watching the video with patience. If this video is useful to you, please like it so that inspired from it I may bring more useful videos before you in future. Please share it to your friends for their benefit and subscribe my channel if you have not subscribed my channel yet, so that you may get information regarding my new videos in time. Thank you again.